In this lesson, we'll finish our asteroid and alternate charge and upgrading spawning functionality. We'll also implement the ability to adjust the amount of hits an asteroid or enemy can take, as well as the amount of damage it must take from the laser beam before they're destroyed. In the link in the description, you'll find a link to freely download the assets and scripts or macro we created in this video. Feel free to download them and follow along, dissect the macro, or to simply use the completed effect in your game or project. Before we begin, let's go over the changes and improvements that we've made between videos, all of which will be available using the provided sprite sheets. One of the changes that we made was to our game over screen. Since the original was simply a duplicate of our start screen, we decided to use and provide a unique set of sprites to better differentiate between the two screens. We also created a new unique animation for our game over screen, and within this animation we simply added a little movement to our background rock formation. Lastly, we've made a prefab for both styles of ships. To do this, we simply made a duplicate of our prefab and adjusted our sprite. And since we created our macro to work independently of any sprite or game object added to our prefab, we can quickly and easily use any design, style, or type of ship. With that said, let's begin by going to our asteroid flow machine. And let's begin by adding our asteroid's point value to our player score. To do this, we want to add a set player score variable after the second game object instantiate node in our destroy on laser trigger enter group. And for our input, we want to use an add node to add our asteroid point value with our player score. However, since our asteroid point value was set to be an object graph variable for our game manager, let's select our game manager, find our asteroid point value object graph variable, right click and hit remove to remove it from our object graph variable list, and then make a scene graph integer variable, which we'll call asteroid point value. However, since we want to have asteroids of different types that may provide more points to the player than our standard asteroid, let's create an object graph integer variable that we'll call added value. So instead of adding our player score to our asteroid point value, we want to add our added score to our asteroid point value, and then add that value to our player score. Before we continue, we also need to address and correct the problem with the alternate fire laser beam. Currently, our asteroid is set to destroy any object with the laser tag on contact, which includes both our laser blast and our laser beam. So in order to correct this, we first need to go to our prefab folder and find our laser beam prefab. Let's open our prefab and let's create a new tag, which we'll call laser beam. And let's change the tag of our laser beam sprite from laser to our new laser beam tag. And let's exit our prefab and go back to our asteroid graph. So let's start by separating our node group, and we'll make our separation after our game object destroy node and before our first game object instantiate node. Since our process is the same for both our laser beam and our laser blast, aside from destroying our laser blast game object, we can simply use a custom event to activate our node group, which will allow us to not have to have repetitive nodes within our graph. And let's create a custom event after our game object destroy node, which we're going to call destroy self. And let's duplicate our removed node group, and in the compare tag node, we're going to use our laser beam tag. And we also want to remove our game object destroy node and get game object node, and simply connect our set current position variable to our custom event trigger node. Currently, our asteroid is set to destroy itself after a single laser beam blast, or if it comes into contact with our laser beam. However, we want to create multiple types of asteroids and have all of them use the same macro, which means some of our asteroids will need to be hit more than once with our laser blast, or will be required to hit a lot longer with our laser beam. So in order to do this, we'll need to create an object graph integer variable, which we'll call hit count. We'll use 1 as our default value. However, since this is an object graph variable, we'll be able to adjust it for each prefab and not have it affect our macro as a whole. And in order to add this to our graph, we want to place a hit count set variable node after our branch and before our current position. For our value, we want to use a subtraction node, and we want to subtract 1 from our hit count. This means every time the enemy is hit, their hit count continues to decrease. From there, we want to use another branch node, and in this branch, we want to see if our hit count is less or equal to 0. If it is, then we'll set our current position variable, destroy our laser game object, and then start the destroy self custom event trigger. And since our laser blast needs to be destroyed upon hitting the asteroid, let's move this node and place it after we initially set our hit count variable. With that complete, let's test our functionality. But before we do, let's set up the first part of our laser beam. We'll break our laser beam attack into 2 parts. The first part will be for our normal asteroids that require a single hit to destroy. The second part will be for asteroids that require multiple hits. With that said, let's add another branch node in our laser beam group, and we'll place it after our first branch node and before our set current position variable. And for the input, we simply want to see if our hit count is less or equal to 1. If it is, we want it to then set the current position and proceed to our custom event. Lastly, since we're no longer using a wait node in these groups, we can uncheck coroutine, but we need to check our coroutine for our destroy self custom event that we just created. With that complete, let's proceed to testing our functionality. We can see with our new functionality, our laser beam not only destroys our asteroid, but stays on screen. If we select our asteroid and change our hit count from 1 to 3, we can see now that the amount of hits the enemy can take directly correlates with the value we specified in the hit count. Since we'll be using many of the same nodes, let's begin by selecting and duplicating our laser beam trigger enter node group. For our new set of nodes, the first thing we'll do is replace our on trigger enter event with an on trigger stay event. Next, after our first branch node, we want to create a set hit count variable node. For our input value, we want to subtract the hit count by 0.1. And lastly, let's change our less than or equal to node from 1 to 0. And to ensure that our explosion position always occurs in the right place, in all of our asteroid rock trigger node groups, instead of getting the position from the laser trigger collider, let's change that to self. This way we can ensure that the asteroid's explosion and debris will always be set to spawn on the exact position of the asteroid itself. With that complete, let's go into our game and test our laser beam effect. And let's set our hit count from 1 to 10. We can now see within our hit count that our laser is continuously lowering our hit count number. Another thing you might have noticed during gameplay is the fact that even after shooting our laser, our charge number remained the same in our display. So let's select our spaceship macro, and at the end of our alternate fire laser beam group of nodes, let's add our display charge custom event that we created in our game menu manager. And we'll need to be sure to set our game object target as our Astro Galaxy game manager variable. We can see now when we fire a charge, our number reduces, and when we no longer have any charges we can fire, our number is reduced to 0. Now that the correct number is displaying in our display charge, let's finish setting up the functionality to display the player's current score. We'll start by going back into our asteroid, and let's change the name of our add score custom event trigger to check score, which is a more accurate name of what our node group will be doing. Let's now go in the playing state of our game manager, and let's create a check score custom event. Before we begin, let's first go over the logic that we want to implement. We want our check score group of nodes to check and see if the player has earned enough points to spawn an upgrade or an additional alternate fire charge. Additionally, we want the amount of points the player needs to get for these upgrades to increase each time a charge or upgrade is earned. Lastly, we wanted to then display the player's current score which we can do by simply sending the display score custom event that we set up in our previous lesson. So we'll begin with the branch node, and we'll use that to see if our player score is greater or equal to our points for alternate charge value. If it isn't, we simply want it to trigger our display scores custom event. If it's true, we want it to then go to a game object instantiate node so we can instantiate our alternate charge sprite prefab. For our position, we want to use the transform alternate spawn point transform variable, and for our rotation, we'll simply use a blank quaternion. We'll first need to create two scene graph variables, one for our alternate charge sprite prefab and the other for our upgrade sprite prefab. Once created, we'll place our prefabs as their values. And let's now use our alternate charge sprite prefab variable as the input game object for our game object instantiate node. Once our object is instantiated, we want to then set a new value for our points for alternate charge variable. To do this, we need to multiply our points for alternate charge variable by a value. However, we also need to first add that value by our point multiplier value. So for our input number, we're going to choose 2, and we're going to put 0.5 into our point multiplier. This way, our player will need to get more than twice the amount of points to get subsequent charges. Lastly, we'll then trigger our display score custom event so the player can see their new score. And since the name of our point multiplier variable can be somewhat confusing, we're going to change the name of that variable from point multiplier to point offset. With that complete, let's select our group of nodes and we'll duplicate them to create our upgrade sprite spawn. We'll begin by changing our points for alternate spawn to points for upgrade. We'll then change the input for our game object instantiate node to spawn our upgrade sprite prefab and to use our upgrade spawn position transform. And we'll then change our set and get variable nodes to points for upgrade. Lastly, before we instantiate our upgrade sprite prefab, we first want to check and see if the player is already upgraded. If they aren't, we can then spawn the prefab to allow the player to upgrade their ship. If they are, we don't want to spawn our prefab, and we can simply set a new value for the points to receive a new upgrade. With that complete, let's now go and test out our graph. For testing purposes, let's change our asteroid speed to 25 so it moves much slower, and let's change our asteroid point value to 10. Let's change our points for upgrade to 20 and our points for alternate charge to 10. Lastly, for our points for upgrade and point for alternate charge set variables, after our multiply node, we then want to use a round node. This way, we'll always get a round integer instead of a float with decimal. And we also want to be sure that we use a transform get position node to spawn the locations for alternate charge and upgrade sprite. With that complete, let's now test out our graph. To do so, let's duplicate a few of our asteroids. For testing purposes, we'll change the sprites of the asteroids with adjusted hit counts or added point values. We can see once we've shot our rock that we adjusted our hit points as well as our additional point value, that we not only got our regular 10 points for destroying our asteroid, but we also got the additional 20 points, which we set in our added point value. With our ship, asteroids, and menus complete, in our next lesson, we'll create our asteroid spawning and level progression mechanics.
Don't forget to subscribe and hit that notification bell to be the first to see this and many other tutorials, game development tips, and free game asset giveaways.